Now, type of chemical reaction is of basically 5 types, that is combination reaction, decomposition reaction, displacement reaction, double displacement reaction, oxidation and reduction, and we can also see that redox reaction. Now, from out of 5 of these types, you have already learned these 4 types of reactions, combination reaction, I think in your class 7th. Okay, if you remember it. And again, we also revise in our classes 8th and 9th as well. So combination reaction simply means when 2 different elements combine together, it is called as a combination reaction. Decomposition reaction, when a compound breaks down into simpler compounds, is called as decomposition reaction. Displacement reaction, this also you have learned that when a metal which is more reactive displaces the other less reactive metal from its salt solution, is called as displacement reaction. Double displacement reaction, when there is the displacement of both the salts from their salt compounds. The next one is oxidation and reduction or redox reaction. In any reaction, when there is removal of hydrogen or addition of oxygen, it is called as oxidation reaction, and when there is addition of hydrogen or removal of oxygen, is called as reaction. Now, many reactions are in any reaction there is oxidation and reduction, both are taking place at the same time, so that we can also call is an redox reaction, that is redox reaction, reduction and oxidation both, redox reaction. So moving to our first reaction, that is combination reaction. Now, combination reaction is those reaction in which 2 or more substances combine to form a single substance. When 2 or more substances combine together, they form a single compound or a single substance, is called as a combination reaction. As the name suggests, the combination reaction, like magnesium reacts with oxygen to give magnesium oxide. So magnesium combines with oxygen and a single compound is formed. That means both 2 elements are combining together and a single product is formed. It is called as a combination reaction. The other example would be CaO, that is CaO is calcium oxide. Okay, it reacts with H2O, that is water. Calcium oxide react with water, gives calcium hydroxide, and heat is produced. So now, because it is a combination reaction is also called as, we can also see that it's an exothermic reaction. Exothermic reaction, if you will remember, the reaction which generates heat, or heat is evolved or heat is produced in this reaction. So CaO is a powder white substance called as quicklime. Okay, when we'll add water to it. Now, how we'll add water to it? There's a simple experiment. When we'll get back to our school, we will do in the laboratory some tests, that we'll take a beaker. Into it we'll add few grams of CaO, that is calcium oxide, powdered form. Into it we'll add some water. Now that water, when we'll add water, we'll stir it, and we have to hold the beaker carefully. We have to take a thick beaker, because what happens is that it produces a lot of heat and calcium hydroxide is formed, that is CaOH whole twice. Calcium hydroxide is formed. We call it slaked lime is formed, and a lot of heat is generated. So it is an exothermic reaction. The other example is sodium reacts with chlorine. Okay, salt is formed, that is NaCl is formed. Again, it is an exothermic reaction. No heat is absorbed in this reaction. So kind of lots of time. This is in exothermic reactions. The other one will be carbon reacts with oxygen. It forms CO2. Okay, so when fuel, we can also take this example of a combustion. Whenever we burn any fuel, fuel is a form of carbon. So fuel is burned in the presence of oxygen, and CO2 is produced. Plus, a lot of heat is also produced. So combination reactions are basically the exothermic reaction. Exothermic reactions are those reactions in which heat is involved, or combination reactions are those reactions in which two or more substances combine to form a single substance. Now the other example would be NH3 ammonia reacts with hydrochloric acids, give NH4Cl. Okay, so this is again an example of combination reaction. So all these, when a single compound is formed, is called as. The other example is ammonia reacts with hydrochloric acids, give NH4Cl, that is ammonium chloride. Again, these two different compounds, NH3 plus HCl, they react with each other and a single compound is formed. This is also a combination reaction. So I think from of all these examples, you have quite understood that what a combination reaction is. Now, the next type of reaction is decomposition reaction. Next is a decomposition reaction. Decomposition reaction are those reactions in which a single compound is break down into the simpler compounds or simpler substance by the action of any energy to it, or we required any energy, a kind of a heat energy or some kind of energy to break down a compound into simpler form. That means those reactions in which a compound splits or breaks down into the two or more simpler substances is called as decomposition reaction. For example, CaCO3 plus heat. CaCO3 is calcium carbonate, which is a white color for substance which you would have seen in the whitewash also. When we whitewash the substance, then the color which appears on the wall is CaCO3. So when we will heat CaCO3, that is calcium carbonate, it will be decomposed or it will be break down into simpler compounds, that is CaO, and CO2 gas is released. Now decomposition reaction is of three types. There are few types of decomposition reaction, that is types of decomposition reactions. Types of decomposition reaction can be easily be explained as there are three types of decomposition reaction, or decomposition reactions can be simply classified into three types. That is thermal decomposition, when we use heat as a form of energy to decompose a chemical compound or to break down a chemical compound, then we'll call it a thermal decomposition. As I've told you that there are three types of decomposition reaction. So one is thermal decomposition, the other will be electrolytic decomposition reaction, and the third one will be photolytic decomposition reaction. All these three types of reactions are very important. Every year some of the questions come in the exam out of these topic. So please go through the topic very carefully and listen each and every word very carefully. Also go through your book thoroughly. So thermal decomposition is when we'll heat. The first example which I gave you, calcium carbonate decomposes into calcium oxide and carbon dioxide is a gas is released on heating. So when we'll heat calcium carbonate, it will decompose into calcium oxide and carbon dioxide is released, that is CaCO3 will heat it or it will undergo decomposition, then CaO and CO2 gas is released. Now here CaCO3 is calcium carbonate and CaO is calcium oxide. For an more easy or more comfortable and more to make you understand people, I've written some terms. It is CaO. Please, you will have to note it down. CaO. Okay, it is calcium oxide, which we also call a lime or quick lime. CaO, calcium oxide. We can call it lime in a common language or a quick lime. CaOH whole twice. Okay, this is called as calcium hydroxide or slake lime. Please don't forget, CaO is calcium oxide and the common name is quicklime or lime. CaOH whole twice, calcium hydroxide, is called as slake lime commonly, and CaCO3, calcium carbonate. Now all these three things are related to each other. How? I'll show you. Okay, when we will add water, I hope you remember this. It was an example of combination reaction, CaO plus water. When we will add water into CaO, then it will form a single substance. In that, heat was released because if you have this CaO, calcium oxide or quicklime powder in a beaker, into it you will add water. Then if you will touch the walls of the beaker, you will find it very hot because there will be formation of CaOH whole twice. That means the formation of calcium hydroxide plus heat will be evolved. So this was an exothermic reaction. Okay, again, when this CaOH whole twice, that means calcium hydroxide, is treated with CO2. Okay, calcium hydroxide is treated with CO2, we get calcium carbonate. What happens when we have to whitewash? If you have seen a whitewashing of the houses, they take this powder. The powder is known as calcium oxide, which we call as chuna in Hindi also, no? Chuna. It is mixed with the water, then calcium hydroxide is formed. Now this calcium hydroxide is applied on the wall. Okay, so after the application of this calcium hydroxide substance on the wall, it reacts with carbon dioxide present in the air, and then a white layer of CaCO3, calcium carbonate, is formed, which appears to be a shiny in color, and some water is released. Now if we will heat this CaCO3, what we'll get? Again, we will get what? We will get CaO. Okay, this will be our decomposition reaction. If we'll heat that CaCO3, like if we'll heat, we will get CaO plus H2O, CaOH whole twice. We will react it with carbon dioxide, we will get CaCO3, and then when CaCO3 is heated, we again get CaO, the very first product. Okay, so now remember, CaO, calcium oxide, quicklime, CaOH whole twice, calcium hydroxide, slake lime, and CaCO3, calcium carbonate. Okay, so this was the first example of thermal decomposition. Now there are many other examples of thermal decomposition as well, which I will be telling you. That is, okay, decomposition reaction. All these are the example of thermal decomposition. Okay, so if you will heat potassium chlorate, okay, so you will get potassium chloride, KClO3. We'll heat it, we'll get potassium chloride, and water, oxygen will be released. So this is a very important reaction. If we'll heat ferrous sulfate, okay, if we'll heat ferrous sulfate, we will get ferric oxide, Fe2O3, and SO2, sulfur dioxide and sulfur trioxide. Now ferrous sulfate is green in color, okay, but when we will heat it, it will decompose and it will break down into simple compound, that is ferric oxide, okay, which is white. In the previous state, it's white in color, and then it becomes brown in color. So basically, the green color of ferrous sulfate changes into ferric oxide, which is brown in color, and a smell of burning of sulfur comes out from the reaction. So decomposition reaction, the ferrous sulfate is decomposed or break down into ferric oxide, which is brown in color, along with sulfur dioxide and sulfur trioxide is released. The other example is lead nitrate. Okay, PbNO3 whole twice is heated, then we get lead oxide, along with that we get NO2, okay, and oxygen is released. So these were the example of decomposition reactions. Now the second one is electrolytic. This is the most important thing. Many times question comes from this topic. So the other one is electrolytic decomposition reaction, or we can also call it as electrolysis, or by the help of electric current. When will pass electric current? So this electrolytic decomposition reaction is carried out. So how it is carried out? That means when the electrolysis of water is done, when will break down the water, when electric current is passed through the water is breaks into its ion, or it is dissociated into its ion, that is hydrogen and oxygen. So when will pass electric current, so it will decompose into its ion or dissociate into its ion, which is a type of a decomposition reaction, and it is an electrolytic decomposition reaction. I repeat, there are three types of decomposition reaction. That is thermal decomposition, in which will give heat. The other one is electrolytic decomposition, in which will give electricity or electric current, and the decomposition will be carried out with the help of electric current. So there is an activity in your book. You have to go through to all the activities. Please read all the activities carefully, because they are very important. Sometimes you have also to exams, in the exams questions comes to draw the diagram as well along with the activities. So here is a little diagram. There is an activity in your book. Please go through NCERT book. In it you'll take a plastic mug. It's not very good diagram, but you just have to get into this. You'll have a plastic mug. You'll make two holes in the bottom of the mug, okay, so that you can place two test tube in the inverted position. A test tube in the inverted position. Into it there are two rods, that is carbon rods, graphite rods, okay, and we'll connect those rods with the battery, 6-volt battery. Positive terminal and the negative terminal. The positive is called as anode and the negative terminal is called as cathode. So the graphite rod, which is connected to the positive end of the battery, is called as anode, and the graphite rod or the carbon rod, which is connected to the negative end of the battery, is called as cathode. Okay, now we'll fill it with the water and we'll add some acid to it, so that the water will become a electrolyte or a conductor. Okay, now what we'll do is that we'll pass the electric current. And what we'll see is that after some time the water level rises up in one test tube higher, but the other test tube will have a lower water level. Into it we'll see some bubbles in the test tube. So these bubbles are the gases. The water is made up of two gases, that is oxygen and hydrogen, okay. So when the electrolysis, the process is done, the water is dissociating into its ion and it's breaking down into oxygen and hydrogen, which we can see in the form of bubbles in the test tube. But there is a difference in both the test tube, that the volume of water is less in this cathode, but the volume of water is higher in the anode. That means only this is the amount of gas in this, and the gas is more as compared to the anode. Why is that so? Because in the water, in the formula of water, the oxygen and hydrogen is into the 2:1 ratio, okay. So it's H2O, that is 2 ratio hydrogen and 1 ratio oxygen. So oxygen is by 1 volume and hydrogen is by 2 volume. So this is an example of electrolytic decomposition reaction. Now moving to the third decomposition reaction, that is photolytic decomposition reaction. Now photolytic decomposition reaction means that photo means light, okay. When the decomposition reaction is carried out with the help of light, it's called as photolytic decomposition reaction. Now in this, if we'll take some powdered silver chloride in a watch glass, in a little plate or a little glass tray, and we will keep it into the sunlight for a few few minutes or few hours. After some time, what we'll see is that the shiny silverish whitish color of silver chloride fades away and it turns blackish or grayish in color. So the silver chloride color fades and it turns into black or gray. Actually, you will write gray color because of the photolytic decomposition. That means the silver chloride is break into silver and chlorine gas is released. So this is called as a photolytic decomposition reaction. Silver chloride turns into gray color. So reaction is AgCl. AgCl, silver chloride. Okay, silver chloride will expose it into sunlight. So in the sunlight, it will take the sunlight, the heat from sunlight, it will break down into simpler forms, that is silver and chlorine. Now silver will convert into gray color. It will be no more silverish shade. So this is photolytic decomposition reaction. And the other example is silver bromide. Okay, silver bromide also shows the same kind of reaction. Now silver bromide, if we'll expose it into the sunlight, silver bromide, again the bromine gas will be released and the silver will turn into gray color. Again silver AgBr, sunlight. This is also a very important. All these three types of decomposition reactions are very important. You have to learn all three. It can come for a long question also. Also silver bromide, when will expose to the sunlight, it will be a photolytic decomposition and it will break down into silver and bromine gas, and silver the color will be also changed. Okay, so this decomposition reaction are mostly endothermic reaction. Now why they are called as endothermic reaction? Because heat is absorbed in these reaction, because heat is very important. We are providing heat, or we are providing energy in the form of heat, in the form of light, in the form of electric current. So basically we are giving some energy. So energy is absorbed. When energy is absorbed, we call it as endothermic reaction, because in this type, all three reactions, the heat is absorbed, energy is absorbed from the surrounding. That is why it is called as the endothermic reaction. The next reaction, that is displacement reaction. Displacement reaction are those reactions in which one element takes place of the other element, or it displaces the lesser reactive elements from its salt solution, is called as a displacement reaction. The definition would be those reactions in which one element takes the place of another element in a compound are known as the displacement reaction. You have already done few questions of these in your previous classes. I hope you remember that. An easy example will be copper sulfate. We'll take, I have written AQ here, S here, AQ here, and again S here. AQ denotes for aqueous solution, S means solid, AQ again aqueous, and S means solid. So CuSO4 is a salt solution. We have copper sulfate is dissolved in a water, so it is a salt solution. We'll take a test tube. Into it we'll add water. Into it we'll add some copper sulfate. We'll make a solution. After that we'll add some zinc granules to it. We'll see that the color, the blue color of copper sulfate will be changed into colorless, and we'll see a deposition of a brown substance into the test tube, into the bottom of the test tube. So when copper sulfate reacts with zinc, zinc being more reactive than copper, displaces the copper from its salt solution and forms zinc sulfate. Now this zinc has displaced this copper from its solution and it get attached to it, and copper is left free. So displaced, like zinc has displaced copper from its salt solution, and here it's formed zinc sulfate solution. So copper is in blue in color, zinc is silverish whitish in color, When zinc sulfate is formed, it will be a colorless solution. There will be no more any blue color, and copper will be deposited. Copper is in red brown in color. It will be deposited in the bottom of the test tube. Example of displacement reaction is when copper sulfate reacts with iron, it produces iron sulfate plus copper, or we can also say ferrous sulfate plus copper. So copper sulfate is, as you all know, it's blue in color. Copper sulfate solution is blue in color. Iron is reddish or brownish or grayish in color. When it reacts with iron, now iron is more reactive. Now to do the displacement reaction or to find out whether a reaction can be a displacement reaction or not, you have to learn the reactivity series of metal. You have learned in your class 8 and 9. If you don't remember, I will give you again the reactivity series in the next video. Now, since iron is more reactive than copper, so it can easily displace the copper from its salt solution and forms ferrous sulfate, and copper is left away. So in a test tube, when you will take a solution of copper sulfate and into it you will add few granules of copper, what we'll see that the blue color of copper sulfate will fade away and it will turn into greenish color of ferrous sulfate, and then there will be a deposition of red brown color of copper into the bottom of the test tube. That means copper sulfate blue in color, iron reddish brown or green color. It will form a greenish solution of iron sulfate or ferrous sulfate, and copper is released. Now the one more example of displacement reaction is copper chloride reacts with lead. It forms lead chloride because again lead is more reactive than copper, so lead can easily displace copper from its chloride solution and it will form lead chloride, which is copper chloride is greenish solution. Okay, now remember copper sulfate is blue color solution, but copper sulfide chloride is green color solution. Lead is bluish grayish color, and then lead chloride will be a colorless solution. That means CuCl2 plus Pb, that is lead, gives PbCl2, that is lead chloride, just colorless solution, and copper will be left behind in a red or brown color. So lead is able to displace copper from its copper chloride solution because lead is more reactive than copper. Along with this, I will give you a brief review of endothermic and exothermic reaction, because in the videos I have just told you orally about endothermic and exothermic reaction. Now you can also write the notes like endothermic and exothermic reaction. How are they different from each other? In one, heat is absorbed. In the endothermic reaction, heat is absorbed, and in the exothermic reaction, heat is evolved or heat is produced. Example, all the combination reaction are called as an exothermic reaction, and all the decomposition reaction are endothermic reaction because they need any sort of heat or light or electric current. That means they need energy to undergo the reaction. That means it is endothermic, heat is absorbed, and in the exo, heat is produced or evolved. Decomposition reaction are the endothermic reaction, and all the combustion when we'll burn anything, means we'll burn carbon in the presence of oxygen or we'll burn any other thing, it will call as an exothermic reaction because heat is produced into it. Now electrolysis of water from hydrogen and to form hydrogen and oxygen is an endothermic reaction. That means H2O, heat will be in the form of electric current. It will break down the hydrogen and oxygen into its ion. That means energy is absorbed in the form of electricity. Respiration is an exothermic process. Exo means heat is evolved or heat is produced. That means when we respire, the energy is produced, that is glucose, that's C6H12O6. When combines with oxygen, I hope you remember about the cellular respiration. C6H12O6 is the formula of glucose, combines with oxygen. 6. Why I have written 6? Because it has to be balanced to fulfill the law of conservation of mass. It gives 6 CO2. CO2 gas is released. Water is released when we breathe out. We release CO2 gas, we release a few vapors of water, and we get the energy to do work. So energy in the form of, or we can say heat in the form of energy is produced. So exothermic reaction is when heat is produced or heat is evolved, and endothermic when heat is absorbed. Now today we have learned very important topics of our chapter. We have learned about types of chemical reactions. Out of those 5 types of reactions, we have learned 3 chemical reactions, that is combination reaction, decomposition reaction, and displacement reaction. Still 2 reactions are left out, that is double displacement and redox reaction, that is oxidation and reduction. I hope all the topics are clear which I have taken today. So by the end of the video, I would like you to do some worksheet questions so that I can be assured that you have understood the topic very thoroughly. What you will do is that you have to write down the questions and you have to solve these questions, and in the next video I will be solving these questions for you, but you have to give a try by yourself so that you can also revise what you have learned. So all the questions are from the topic which I have covered today. So they are not very tough, they are very easy. So for the first question, you have to find out the types of reactions. You have to tell about which type of reaction is this. Now CaCO3, it gives CaO and CO2. So you have to write what kind of reaction is this. You have learned 3 types of reactions today, so you can write the answer very easily. The next one is CaO plus H2O gives CaOH whole twice. Again, this is also very easy. You will be able to solve this. The other one is FeSO4 gives Fe2O3 plus SO2 plus SO3. Also, you have done this. The last one is A plus BC gives AC and B. You have to find out the types of reactions. The other question is, why is respiration called as exothermic reaction? Okay, this is also a very easy question. We have also covered this. You can write the answer by your own. I hope you all will be able to do by the time I will make the next video. Write one equation each of for decomposition reaction where energy is supplied in the form of heat. Now in this you have to write all the reactions of the decomposition reaction in which the energy, because decomposition reaction is a reaction in which the energy is supplied. So this energy will be supplied in the form of heat, in the form of light, and in the form of electricity. So you have to write all the 3 reactions in which you will be showing that how the energy is supplied in the form of heat, light, and electricity. The next question, why is the amount of gas collected in one of the test tubes in the electrolytic decomposition of water double of the amount collected in the other? Name this gas. Now in that experiment, there is an activity in your book as well. You will find it out in the section of decomposition reaction of electrolytic decomposition. There few gases are collected in the test tube. One is you have to name the gas. I don't like to tell you the answer, but there is a few things. When we will get those bubbles, we have to check it out whether it's oxygen or hydrogen. We will not be able to know, no? So we'll bring a burning candle in front of the mouth of the test tube, and if the flame of the candle it becomes brighter, that means that is oxygen, because oxygen is the support of combustion. And if the flame will get a popping sound again, that means it's hydrogen, because hydrogen burns with a popping sound. Now you have to tell that why there is a different level of the gases. So you have done this question as well. The last one is, a solution of a substance X is used for whitewashing. Name the substance X and write its formula. Write the reaction of substance X named in the above with water. So this is also a very easy question. I hope you will be able to do all the questions. So by the time we'll meet again, you will be solving these questions. Thank you.